the assignment for next one. Preposition. Let V be the vector space over field F which is generated by a finite number of vectors. Then any independent set of vectors in V is finite and contains no more than n vectors. Which means that independent set has only n vectors only, not more than n. Because if vectors are more than n, which means n plus 1 vectors, then the set will be linearly dependent. So we have to prove that any independent, we have to prove that for n vectors we have a linearly independent set, right? So let's start with the proof. Let suppose okay, what we have given to us, we have v1, v2, v3 up to vn. These are the generating set for v, and we have to consider the vectors, right? No more than n vectors. We have to consider some, okay, I again name that vectors as w1, w2 up to, let's say, wm, right, in v, where m is greater than n. I'm taking the greater than n number, and I will prove that those are linearly dependent, because I have to prove that up to n vectors the set is linearly independent. So let me take up to m, where m is greater than n. So I will prove that up to m the set is linearly dependent. If I prove that for greater than n we have a linearly dependent set, then it is obvious. The result is obvious. Okay, so let me choose. Let w1, w2, w3 up to wm be any m vectors in V where m is strictly greater than n. Right? Now, since again the same proof that we have done in the previous assignment, very easy. Now, since let me take any wj from here which belongs to V. Yes? Yes. Okay, for all. Now here j is from, because I'm having from 1 to, sorry, m. So j is from 1 to m. And the generating set of V is from V1, V2 up to Vn. Right? Okay. Now because Wj belongs to V, which means because it is given to us that this is the generating set, which means every element of V is a linear combinations of these vectors. So every element of V, I have taken again one specific one, Wj. So for Wj, I am taking the scalars to be, okay, for V1, I am taking alpha 1 j. I have to write the specific scalar. Then alpha 2 j, alpha 3 j up to alpha n j, such that this Wj is a linear combinations of this. So alpha 1 j V1, alpha 2 j V2, alpha 3j V3, so on, alpha nj Vn. So I'm writing this complete as a summation. Summation I going from 1 to n, alpha. Now j is already written, so I have to take the summation over this I, that is 1, 2, 3. Let me name this as I. So I, j is already I am having. And if this is 1, this is also 1, this is 2, this is also 2. So if this is I, then this is also I. So I'm writing V, I. And I, the summation from 1 to n. Right? Mark this as 1. Now required to prove that these W1, W2, W3, Wm are linearly dependent. Right? For that, again, we have to take the linear combinations of these. So let me choose a scalar simple C1, C2, because there is no any specific. For specific scalars, then we choose when we count a specific Wj from V. Now here it is simple. Just write the simple linear combinations. Let C1 W1 plus C2 W2 plus C3 W3 up to Cm Wm is equal to 0. Then we take the summation of this. Now summation is because we have chosen W1, W2, W3 up to Wm as Wj's, right? So we have to write here for summation the j's. So we write Cj, Wj, j going from 1 to m. Clear? Okay. There in the previous assignment we are having n plus 1. So it is same. I have written in the very start point that m is greater than n. That is one and the same thing. Okay. Now putting the value of Wj here, summation going from j to m, Cj, the value of Wj is summation going from 1 to n, I is from 1 to n, alpha ij, Vi is equal to 0. Now taking this summation I going from 1 to n outside, which represents a number of equations, right? Remember that I represents the number of equations because it is on Vi. Taking this j inside, and this summation is on Cj and alpha ij, and the single I going from 1 to n is on Vi equal to 0. Okay, fine. Now these are nothing but the system of linear homogeneous equations having m variables. These always represents the variables and I represents the number of equations. Please remember this. So now I'm taking this, the homogeneous set, to be as j going from 1 to m, alpha ij, Cj. Okay, let me interchange here. This doesn't matter. Okay, so this is equal to 0. This is the system of homogeneous linear equations in m variables. These are variables, right? Now these are m variables and these are number of equations is n. Now number of equations is less than number of variables, n is less than m. So we have, the system is having non-trivial solution, and for non-trivial solution not all the scalars is 0, right? So not all Cj's are 0. Not all C1, C2, M are 0. Now C1, C2, Cm are nothing but linear combinations with W1, W2, W3, Wm. Now not all C1, C2, C3 and Cm are 0, which means W1, W2, W3 up to Wm are linearly dependent. Very good. So W1, W2, W3, Wm are linearly dependent. Thus, any independent set of vectors in V contains no more than n vectors and hence is finite. The meaning is same, right? Because for greater than m we have a linearly dependent vectors, right? So no more than n vectors, which means any independent set of vectors in V contains no more than n vectors. They are having only n vectors for independent. Thank you so much.